Okay, moving on to question 2 right here. We're going to just put this into Desmos and see what we find. So I'm going to go over to Desmos and I'm going to enter a new table. I'm going to get rid of that one. I'm going to plus sign or just this plus right there and then a table. So I've got 460, 12, 180, 23, 345, 37, 555, 48, 720. Now let's show it on the graph. And look at that equation, 15x plus 0. So that tells you your y-intercept is 0. And we look on the graph and it does go through 0, 0. So we can go back over here. Oops, I need to do that. And say this one is proportional. Because we just saw on Desmos that it went through 0, 0. Okay, very good. Now let's keep going. Let's do this one. We're going now on page 140. Use the formula slope m equals y2 minus y1 over x2 minus x1 to calculate the unit rate of change for the data in each table. The rate of change is constant for the data in each table. So if we do that, y2 minus y1 over x2 minus x1, then we'll start here and get 2 minus 1 over 4 minus 2. So what is 2 minus 1? 1. What is 4 minus 2? 2. So that shows us that our slope is 1/2. So now let's do this one. 4 minus 2 over 8 minus 4. 4 minus 2 is 2. 8 minus 4 is 4. Can we simplify that? Yes, we can simplify that to 1/2. If we divide by 2 on the top and the bottom, we would get 1/2. Now, 5 minus 4 over 10 minus 8, 1 over 2. Is that 1/2? Yes. So the slope, the rate of change is constant for the data in each table. Yes. The slope is 1/2 every time we did it. We got 1/2. Okay. So that's how we could figure out that this relationship is linear because the slope between each and every point is 1/2. Okay, let's do it again right here. Let's try it on Desmos and see what happens. If we enter in the Desmos and do a table and we say -2, 8, 0, 0, 2, -8, and 4, -16. When we graph it, it tells us y equals -4x plus 0. It's a proportional relationship. And we knew that because we had 0, 0 on our table. So we knew it was going to be proportional, but it is going to have a slope of -4. So we could write that equation as y equals -4x plus 0. Or y equals -4x. We don't have to have the plus 0. But you can find the slope by plugging all of the values in your table into Desmos to make sure that you've got a linear relationship and make sure that it graphs as a straight line. And then that gives you that equation of a line, y equals mx plus b. So let's review that real quick. Slope, y-intercept. What is the x and the y? That's just your points on your line, the x and y that you could plug in. Okay, let's do another one. Let me see what else I had for us to do. Okay, let's do page 147, number 6. Josh is renewing a magazine subscription. He can renew the magazine subscription for 3 years for $26 or 5 years for $38. What is the unit rate of the subscription cost per year? So slope, oops, I need to do that. Slope, rate of change is another way to say it. And then also when we see unit rate. So 3 years for $26, 5 years for $38. So are those going to be X and Y values? Yes. So which one is going to be the X? Remember, time is an independent variable. And X is independent variable. Y is dependent variable. So we could say 3 years and $26 and 5 years and $38. So let's just do our formula. Y2 minus Y1 over X2 minus X1. 38 minus 26 over 5 minus 3. So 38 minus 26 is going to give me 12. 5 minus 3 is going to give me 2. And those divide, give me 6. Okay, that's all you have to do. It just says, what is the unit rate of the subscription cost per year? So it'll be $6 per year. Okay, moving on. Let's do this one next page, number 148. Number 1, determine whether the relationship represented in the tables are linear. If so, calculate the rate of change. That is the slope. Well, let's go over to Desmos. I need to do that. Let me just split the view and go over to Desmos. So what is our table going to look like? Well, we're going to have 0 and 12,000, 3 and 36,000, 5 and 52,000, 9 and 84,000. So let's graph it. Oh, look, that says it's got a slope of 8,000. Let's make it smaller and smaller so we can see. Looks like it's going straight up and down. Okay, so, oh, there we go. I pressed the little magnifying glass symbol, and there we see our line. Sometimes our numbers are so big. You see this 84,000 goes with 9. That's really small compared to that big number of 84,000, and 5 going with 52,000. So sometimes you've got to press that magnifying glass to see. So it is a linear relationship. Y equals 8,000 x plus 12,000. That follows our y equals mx plus b format, but the numbers are just really big. So what would be the rate of change? That's the slope. So it would be 8,000. So we aren't used to working with numbers that big, but sometimes it does happen. So that's how Desmos comes in handy. We could have figured that out by doing y2 minus y1 and x2 minus x1. But I just want to get you more familiar with Desmos and how that works to be able to see your equation of a line that way. Okay, let me see if there's another one. I think I'll probably do one more video. So let me